video, we're going to look at a few examples on solving linear inequalities. When we're solving a linear inequality, we take the exact same steps as we would for an equation, with one exception. When we multiply or divide by a negative number, we need to make sure that we flip the inequality symbol. So let's look at a few examples. We're going to solve our inequality and also graph our solution and write it in interval notation. So again, we solve just like an equation. If I'm isolating x, I'm going to start by subtracting 7 from both sides. 2x is greater than or equal to 2. Divide both sides by 2. Since we're dividing by a positive, no need to flip the inequality symbol. X is greater than or equal to 1. Now, I'm going to set up a very quick graph. You guys can make a more formal graph. We're going to mark our solution of 1 on the number line, and then we're going to look at that statement. It says x is greater than or equal to 1, so we're talking about the values to the right of 1. Since x can equal 1, we will include that value with a bracket. This is similar to a closed circle if you've learned that in previous classes. Now this shaded region is representing our solution, all of the values in our solution. So when we're setting up our interval, we're setting up an interval for this shaded region. Since we read from left to right in everything else, we read from left to right in math, this shaded region begins here at 1 and goes to positive infinity. Since 1 was included on the graph, it's included in our interval. And we never include positive or negative infinity in an interval. We'll always use a parenthesis. (15 plus 2x is less than or equal to 4x minus 7, excuse me. Just like with an equation, we're going to try to combine our variables first, trying to avoid a negative coefficient on x if possible. So I'm going to start by subtracting 2x from both sides. We get 15 is less than or equal to 2x minus 7. We will add 7 to both sides. 15 plus 7 is 22, is less than or equal to 2x. Divide both sides by 2. We get x greater than or equal to 11. Now, when we see this statement reading from left to right, it says 11 is less than or equal to x. A lot of times we'll rewrite this so that our variable comes first. We're essentially just flipping that entire statement. So everything is going to flip, including that inequality. X is greater than or equal to 11. We set up our number line. Here's 11. Since x is greater than 11, we're going to shade to the right. Since x can equal 11, we will use a bracket to include. And now when we're setting up our interval, again, that shaded region represents the interval. We read from left to right. It begins at 11 and goes to positive infinity. Since I included 11 on the graph, I include 11 in my interval. (1 over 2x is less than or equal to x plus 1 over 3 is less than or equal to 3/4. When we have an inequality or an equation with fractions, we want to start by clearing the fractions by multiplying through by our LCD. Our LCD is going to be 12. So I'm going to multiply everything by 12. (12 divided by 2 is 6, is less than or equal to, here, we can show that here. 12 divided by 3 is 4. Now we still have parentheses around that, so we have 4 times x plus 1. 12 divided by 4 is 3. 3 times 3. Now to clear my parentheses in the middle, we're going to distribute that 4. So we have 6 is less than or equal to 4x plus 4 is less than or equal to 9. And now here's where we start isolating x. We know that to get x by itself, we need to subtract 4 from this middle piece. Now we see that there's 3 pieces in this inequality. This is called a compound inequality, which we're going to see more of in another section. But this is a real quick introduction to this. Since I'm adding 4 here, or subtracting 4 here, I'm going to subtract 4 from every different piece of that inequality. We get 6 minus 4 is 2, is less than or equal to 4x, is less than or equal to 9 minus 4 is 5. And now same thing here, when we divide the middle piece by 4, we're going to divide every piece by 4. 2 over 4 simplifies to 1/2, is less than or equal to x, is less than or equal to 5 over 4, which does not simplify. When we set up our number line, 1/2 is smaller than 5 over 4, so it's going to go on the left-hand side. And if you look at your inequality, it looks like x is between those two values, which is exactly what this statement is saying. This statement says that x is greater than 1/2, but also less than 5 over 4, which is this section on the number line between 1/2 and 5 over 4. Since we include both of those, we'll have brackets on both opening towards your shaded region. And our interval begins at 1/2 and ends at 5 over 4. Set up and solve the following inequality. Sue has the following test scores, 81, 72, and 78. What must she get on the 4th test to have a test average of a B? Now, an average of a B is anywhere between 80 and 89. So what this is saying is we want her average to be between an 80 and an 89, which means that the average must be greater than or equal to an 80 or less than or equal to an 89. We're just trying to find out what she needs to be between those two values. Now, how do we find an average? We add up all of our values and divide by how many there are. We're talking about test scores. So we have a test score of 81, 72, 78, and then we have a 4th test which we don't know. There's our unknown x, which we will divide by 4 to find the average. And now we have a similar compound inequality that we saw in the last example. To get rid of this 4 in that middle term, we're going to multiply everything by 4. So if I multiply the middle piece by 4, I multiply the left and the right also by 4. 4 times 80 is 320. Is less than or equal to these 4's, cancel each other out. 81 plus 72 plus 78 plus x is less than or equal to 4 times 89, which I don't have a calculator. Does maybe somebody in the back have a calculator that they can do for me? Or I can go get my phone. Hang on, I'll be right back, guys. Okay, I'm back. Oh, the joys of filming. The sum of these 3 test scores is 231. And 4 times 89 is 356. So we have 320 is less than or equal to 231 plus x is less than or equal to 356. To solve for x, we're going to subtract that 231 from every side. We have 89. 320 minus 231 is 89. Is less than or equal to x is less than or equal to 125. So what this solution tells me is that Sue needs to get a 4th test grade between an 89 and a 125 in order to have a test average of a B. Now, if we're thinking about this in terms of the real world, what does that mean? Are we going to be able to get a test grade of a 125? No, probably not. Certainly not in my test. There's not that much extra credit available, if any. But in this case, we could simply say that Sue needs to get an 89 or greater in order to have a test average of a B. Because even if she gets a 100%, she's still going to get a B, isn't she? That 100 on the test, a perfect score on the test, is not going to get her up to an A. So Sue needs at least an 89% in order to get that B. Now, in those few examples that I just gave you, I realized that I missed a pretty important concept. So I'm going to come up with another example for you guys, just to make sure that you guys see that issue of dividing by the negative. It's very similar to the first one. So let's look at the inequality negative 2x plus 7 is greater than or equal to 9. We'll subtract 7 from both sides. So we have negative 2x is greater than or equal to 2. And now here we're going to have to divide by negative 2 in order to get x by itself. So this is where we need to flip that inequality symbol. Before I simplify anything, I'm going to go ahead and flip that symbol so I don't forget. We have x on this side. 2 divided by negative 2 is negative 1. So we marked negative 1 on our number line. Since x is less than or equal to negative 1, we're shading to the left. And since x can equal negative 1, we will include that with a bracket. And when we're setting up our interval, again, read that shaded region on your graph from left to right. So we start down here, which is represented by negative infinity, and it ends at negative 1. A bracket on the graph is a bracket in your interval, and we never include positive or negative infinity. So that last example really does help us see that restriction or that condition of dividing by a negative. Again, multiplying by a negative would also cause us to flip that inequality symbol. So if I had a fraction, like multiplying by negative 1/2, and I had to multiply both sides by negative 2 to clear that, same thing, you'd flip that inequality symbol. Thank you guys very much. We'll see you guys next time.